Hello, my name is Sasha Powell, and this is my lab report for Lab 1 for Physics 2212, Charged Tapes. So the purpose of this lab is to observe the interactions between two charged pieces of tape, simulate these interactions using GlowScript, and calculate the charge of the tape and the number of electrons lost or gained. The results of this experiment were that the positive charges in the tape results in repulsion when they are near each other. The electric charge on a single piece of tape is 8.95 E negative 9 coulombs, and each piece of tape lost 5.59 E 10 electrons. So some important concepts are Newton's second law, F equals ma, force equals mass times acceleration, and Coulomb's law, which gives the electric force between 2 point charges, where force is equal to Coulomb's constant times both of the point charges over r squared. The system in this experiment was tape B and the surroundings were tape A. The initial conditions were the tape mass was 2.5 E negative 4, the tape length was 0.2 meters, and the tape width was 0.02 meters. The distance between the two tapes was 0.026 meters, and the tape was attracted to a plastic pen and repelled by the other piece of tape. Some assumptions were made in order for this experiment to work. The assumptions were that each tape is a point charge, and each tape has equal charge distributed equally across its length. For my code, I established some constants, Coulomb's constant, 9E9, gravitational constant, which is negative 9.81, the distance between the two pieces of tape, 0.017, and the tape mass, which is 0.000254. So the force due to gravity was tape mass times the gravitational force, or the gravitational constant, my bad. And the force due to the electric interactions between the two pieces of tape was the absolute value of that force. Since the force of gravity is going to be negative, and the force of the electric field is going to be positive, since it has to point in the opposite direction in order for the tape to be remaining stationary. It has to be equal and opposite. So then I printed those two things, and then I did the visual representation by making both of the tapes those point charges, r distance away from each other, and then I made arrows for the gravitational force and the electric force, pointing in the direction and the magnitude of those two things that I already calculated, F grav and F elect. Then I calculated Q squared using Coulomb's law and the assumption that both of the tapes had the same charge. So F electric times the distance between them squared over Coulomb's constant. And then I got Q by taking the square root of that. And then I printed Q, and then I took the difference of electrons, how many electrons the tape was missing, by taking Q divided by the charge of one electron, and then I printed that out. So as you can see, my code output is this lovely picture that has the two dots as the tapes, which are that distance apart, r distance apart. And then it has two arrows that are equal in magnitude but pointing in opposite directions. One's pointing straight down and one's pointing straight up. I have the gravitational force printed. I have the electric force printed. Those are negative 2.49 E negative 3 and 2.49 E negative 3. And then the charge on each individual tape is 8.94 E negative 9, and each tape is deficient 5.59 E 10 electrons. So some possible sources of error are that some charge may have been lost while handling the tape, additional forces in the surroundings were not accounted for, the tapes were not actually point charges, and the charges of the two tapes may not have been equal, which are those assumptions that we made earlier. What if the signs of protons and electrons were switched? What would change about the observations you made with your tapes and other charged objects? These interactions would remain exactly the same, because although the charges would be switched, it like still repels like and opposites still attract. So if both of them were switched, then the observations made about the interactions of the tapes with other charged objects would remain exactly the same. And then the two computational values for Q, point charge model versus line charge model, will be different. Why are they different? Which value is more likely to be closer to the real value, and why? So that assumption that we took that the tapes were actually point charges is not true. The charge would actually be spread across the tape. It may or may not be even, but the middle of the tape, the point in the middle of the tape is not the only place where charge exists. And so these charges would be interacting differently with each other. They would be different distances apart and going in different directions based on which charges they were interacting, because every charge would interact on one piece of tape would interact with every other charge on the other piece of tape, which would be very difficult to compute, which is why we assumed that they were going to be point charges. But the value of the line charge model would be much closer to the real value, because a line is much closer to the shape of a piece of tape than a point charge. Thank you.